Hi everyone, welcome to the session on Agile methodology. In this session, we are going to see the Agile requirements modeling and generation from Unit 4 Agility and Requirements Engineering. So, in the previous part, we learned how agile teams are prioritize requirements, but once requirements are identified and prioritized, the next step is to model and generate them clearly so that developer, testers, and product owners have shared understanding. In Agile, we do not use heavy documentation like traditional method. Instead, we use lightweight models and visual techniques such as user stories, use case diagrams, storyboards, acceptance criteria, and prototypes. These techniques help teams understand requirements quickly and collaborate better. So, in this topic, we will explore how agile teams represent the requirements in a simple and visual format, how those requirements are communicated to team, and how they evolving during the development through the feedback. So let's move into the next slide, that is agile requirements modeling and generation. Agile requirements modeling and generation focus on the transforming the abstract ideas into structured, visual, and actionable requirements. It provides a clear understanding of workflows, dependencies, and user interactions across the agile life cycles. The goal is to enhance the collaboration between technical and business teams through shared visualization. Models in Agile are lightweight, continuously evolving artifacts that adapt with every sprint iterations. They help to avoid miscommunications and bridge the gap between concept, design, and delivery. Requirement generation ensures that every user need is to translate into measurable development tasks. Ultimately, modeling and generation create a transparency, agility, and faster product validation. In next slides, we will see the importance of modeling in Agile. Modeling simplifies the complex systems into understandable visual representation for all team members. It improves the cross-functional communication and reduces the dependency on lengthy documentation. By visualizing the flow, teams can validate the assumptions early and reduce the rework later. Agile modeling support iterative refinement. Every sprint adds new insight to the model. Visual models align business expectations with developer understandings. They promote adaptive planning by illustrating the changing requirements clearly. Modeling makes the Agile project more predictable, traceable, and user focused. In next slide, we'll see the behavior models. It captures how the system responds to the various input actions or event. Use case diagram show the interaction between the user and the system, defining the primary user goals. The state diagram discuss transition between the different operational states of a component or systems, and the storyboards visualize the step-by-step experience of users and it offering the early design feedback. So each behavior model provides insight into how features behave in real world usage. So in Agile teams use these models to validate the functionality before coding starts. Uh, this ensures shared understanding, reducing the chance of misinterpretations. And next one is the user story mapping. User story mapping visually connects customer goals to corresponding system features and stories. It organizes the user journey into activities, tasks, and stories aligned with business objective. The map allows teams to plan releases and prioritize the features based on value and user flow. It provides the clarity on dependency, helping teams see what must come first. By mapping the entire journey, everyone understands how features contribute to the big picture. Story mapping fosters collaborations by involving the product owners, users, and developer. It turns the abstract requirement into actionable roadmap for incremental delivery. And next one is acceptance test driven development. Acceptance test driven development ensures that requirements are defined as the acceptance test before development begins. These tests become a living documentation of system behavior, ensuring the consistency interpretation. Stakeholders, testers, and developers collaborate to write test case representing the requirements. It guarantees that all parties share a common understanding of what done means for each story. Tests evolve with changes in requirement, maintaining traceability and accuracy. Acceptance test driven development integrates them naturally into continuous integration pipelines for fast validation. This approach promotes the quality, transparency, and stakeholders' confidence. And the next one is the collaborative modeling. Collaborative modeling brings together the stakeholders, developers, testers, and analysts in joint sessions. It replaces the individual documentation with shared exploration of ideas through the whiteboards and diagrams. Active participation from everyone increases ownership and reduces the miscommunication. Workshop create a real-time consensus and faster decision making during the sprints. This process nurtures the creativity and ensures that every perspective is considered. Collaborative modeling encourages the shared accountability for product outcomes. It leads to models that are realistic, practical, and aligned with both the business and technical goals. And next one is automation support. Automation in agile modeling reduces the manual effort by generating the documentation and test cases automatically. Tools such as Modulo, Enterprise Architect, and Visual Paradigm enables the rapid model to code generation. This ensures the consistency between the design artifacts and implementation. Automated traceability helps keep all connected artifacts and synchronized during the change cycles. Integration with the DevOps pipelines ensures the model contributes directly to the continuous delivery. Automated testing based on models, it saves times and increases the accuracy in validation. Automation transform agile modeling into an efficient repeatable process. The next one is the integrating models with the agile artifacts. Models integrate seamlessly with the agile artifacts such as the user stories, backlogs, and the sprint boards. They enrich textual stories by adding the visual context to clarify the intent and dependencies. In tools like Jira, Confluence, diagrams are linked directly to backlog items for traceability. Each model evolves incrementally, updating the alongside sprint progress. This ensures design, development, and testing remain the synchronized throughout the project. Integration fosters better understanding of the impact of each change. It unifies agile documentation, reducing the duplications and misalignment. And next one is the tool for agile modeling and generation. Agile teams use the combination of modeling and collaboration tool to streamline the requirements creations. Common tools include Miro, Lucidchart, UML based software, Enterprise Architect. These tools allow remote teams to visualize, edit, and review models collaboratively. Automation tools generate test script, a report, and diagrams directly from models. Integration platforms connect models with code repositories and CI/CD systems. Selecting the right tool depends on team maturity, scale, and workflow complexity. The chosen tool set should enhance agility, not create unnecessary process overhead. Next one is the overall summary. Agile modeling transforms the work idea into actionable visuals and testable requirements. It supports the fast feedback, adaptability, and clear communications across all stakeholders. Techniques like story mapping and ATTD ensure each requirement is measurable and verifiable. Collaborative modeling builds the shared ownership and reduces the silos within the teams. Automation and integration makes modeling efficient and self-updating across the sprints. The process ensures that the requirements stay relevant and aligned with the changing user needs. Together, modeling and generation enhance agile maturity, quality, and speed of delivery. Thank you.